welcome. Before I begin in my video series discussion of single replacement, I want to introduce the concept of an activity series. Some of this you will be able to predict from the periodic table. Some of it is not so much. It's a little more challenging. In my honors class, this is something I would provide for them. So they would have to interpret this chart. So just so you know the expectations. For AP and IB and hence first year college chemistry, it's much more likely, you may see this, but it's much more likely you are going to have to interpret data of how metals react compared to one another. And understanding this activity series can help you wrap your mind around that. Now, when we talk about activity of metals, the most active metals want to become cations. So they prefer to be the cation. So in a process, if the most active metal is the cation as a product, it will typically be a thermodynamically favorable situation. Our least active metals really prefer to stay in their elemental state. That's why so much jewelry is made out of gold and platinum and silver, because those tend not to react, and so they make beautiful jewelry that is very resilient to our environment around us. So lithium, our most active up here, lithium metal, very soft metal, prefers to be and is found in nature in its oxidized form, where it has lost an electron. And so lithium is so active, and our sodium, so everything from here and above all react spontaneously with water, and it would be lithium. I like to write water as HOH in this case, because you can think of it, water does not dissociate into ions, but you can think of it as lithium grabbing that hydroxide. And then that would leave hydrogen gas all by itself. And then of course you would need to balance that puppy. Okay? And put states. All right, I just want to get you the general concept that solid lithium becomes lithium hydroxide. Hydroxides are called alkalines. So if it's basic, it's an alkaline solution. And that's why we call these the alkaline earth metals, and because they make bases when they are in water. So if you are in IB, what you would want to know for these is these are basic anhydrides. So when they're by themselves without water, that's without water, they're an anhydride. When you put them into water, they're going to make a base. Okay, now this group, everything from above here all the way up, honestly, to get aluminum, magnesium, zinc, you need to have hot water, and you might be able to get those to react. Sometimes you won't see things like aluminum reacting because aluminum has a tendency to make a protective oxide coating. So that would be a protective coating that prevents it from reacting with steam. So to react the aluminum with steam, you might have to take some steel wool and get that oxide off. Okay, so you notice they get progressively more challenging to react. So now everything above the hydrogen on this chart, everything from here on up, these all react with acid. Okay, so if I put some cadmium in acid, a simple acid like HCl, whoops, get my H in there, I would get cadmium chloride plus hydrogen gas if I reacted it with acid. Okay, Now, the ones below hydrogen are fairly non-reactive. You may see silver tarnish. When silver tarnishes, it reacts with sulfur to make silver sulfide. Okay, you may see copper oxidation as well, but these get less and less reactive as we compare to hydrogen on this. Now, the final rule is everything above replaces what's below it. So strontium would replace zinc, so that strontium would be the ion. So if I had strontium metal plus, say, zinc chloride, strontium is above the zinc. Strontium is more active. More active prefers to be the cation, and it's not, so this will happen. Strontium's 2 plus, so it would make strontium chloride plus zinc. Okay? So if it was the other way around, let's say I had iron plus barium chloride. Barium is the more active metal because it's further up on the chart. It prefers to be the cation, and it is the cation, so this would be a no reaction. So that's how you can tell whether a reaction will occur, is you want to figure out which one is more active. The more active prefers to be the cation, and if it's not, you need to react it so it will become the cation. Okay, for nonmetals, most at the beginning level, introductory levels of chemistry would only deal with the halogens, and what's lovely about the halogens is they follow the periodic table. So fluorine is more active than chlorine, is more active than bromine, is more active than iodine. And remember, with halogens, we are looking at the more active prefers to be the anion in a compound. Okay, so as opposed to the cation, because nonmetals like to gain electrons, and fluorine likes electrons more than anything on the whole periodic table, or has, it's not really likes, it's not human emotions, but has a drive to draw electrons towards it. Okay, so that is an activity series. Hopefully that will help you interpret that as we move into single replacement reactions. Thanks for joining me. Good luck with chemistry.